Right now, as you sit in your driveway wondering why your Toyota smells like a burning oil slick and why the top of your engine looks like someone poured a bottle of grease directly onto it, a mechanic somewhere is already mentally calculating how to bill you $800 for a job that costs $3 and takes 90 seconds. That is not an exaggeration. That is the exact racket I am going to dismantle for you today. And by the time this video is over, you will never be afraid of a so-called valve cover gasket quote again. Let me be absolutely direct with you. The repair industry depends on you not knowing the difference between two completely separate components that happen to sit within 2 inches of each other on the top of your engine. One of them is the large rubber perimeter seal that wraps around the entire valve cover, a gasket that costs about $20 and genuinely does fail occasionally after many years. The other is a tiny rubber grommet, roughly the size of a pencil eraser, that holds the positive crankcase ventilation valve in place inside a small hole punched through the top of that same valve cover. This grommet costs $3. It fails constantly. And when it fails, it produces a leak. So visually dramatic, so perfectly convincing, so absolutely terrifying to look at, that virtually every shop owner on Earth will point at the resulting oil pooling and confidently tell you the entire valve cover gasket has catastrophically blown. What they will not tell you, because telling you would immediately end the conversation and eliminate $800 of labor from their invoice, is that a $3 rubber ring is almost always the actual source of every single drop of that oil. To understand why this works as a scam, you need to understand what the positive crankcase ventilation system actually does, because Toyota engineers thought about this problem deeply when they designed these motors. Inside every running engine, the combustion process inside the cylinders is violent and imperfect. A small percentage of combustion gases, carrying vaporized oil with them, inevitably blow past the piston rings and down into the crankcase, the sealed lower cavity of the engine where the oil lives. If you simply let that pressure build with nowhere to go, the crankcase would eventually pressurize to the point where it would force oil past every seal and gasket in the engine simultaneously, and you would have a genuine, catastrophic, engine-destroying mess on your hands. Toyota solved this elegantly. Thanks for watching. The PCV system takes that pressurized, oil-laden vapor and routes it back up through a small valve on top of the engine, where it gets fed back into the intake manifold and burned cleanly during normal combustion. The system keeps the crankcase at a safe, slightly negative pressure, it reduces emissions, and it recycles byproduct vapor rather than venting it into the atmosphere. It is genuinely brilliant engineering. The PCV valve itself is a simple one-way check valve. It opens under vacuum to allow vapor to flow toward the intake, and it closes under positive pressure to prevent backflow. The valve sits inside a small bore in the valve cover, and the only thing sealing the gap between the metal valve and the aluminum hole it sits in is that tiny rubber grommet. That ring is what creates the airtight connection. As long as the grommet is soft, pliable, and properly sized, the system works exactly as Toyota designed it. The vapor flows cleanly. The crankcase pressure stays controlled. No oil escapes from the top of the engine. Here is where the years catch up to you. Toyota shifted aggressively toward high-output, high-efficiency engine designs in the early 2000s, particularly across the 4-cylinder and 6-cylinder motors that ended up in millions of Corollas, Camrys, RAV4S, Tacomas, and Highlanders. These engines run hotter than the motors they replaced, partly because tighter emission standards demanded more complete combustion, and partly because modern engine management systems push these motors closer to their thermal limits to extract every possible mile from a gallon of fuel. The PCV grommet sits directly on top of the valve cover, which is itself sitting directly on top of the hottest part of the entire engine. Cycle after cycle, year after year, that small rubber ring absorbs radiant heat from below and convective heat from the engine bay above. Over time, the rubber compound loses its plasticizers. It oxidizes. It shrinks slightly and hardens from a pliable compressive seal into something closer in texture and behavior to brittle plastic. When that happens, the perfect interference fit between the grommet and the valve cover bore disappears. A gap opens up. And now every time crankcase pressure pushes oil vapor up through the PCV valve, some of that vapor, carrying real liquid oil with it, escapes directly out of that gap and onto the top of the engine. This is where the visual illusion becomes almost perfect. Oil does not simply drip from the grommet hole and fall neatly to the ground in a way that would make diagnosis obvious. Instead, the pressurized vapor carries fine oil droplets that coat the top of the valve cover in a thin, wet film. Engine heat then bakes that film slightly, and road vibration spreads it further in every direction. Within a few weeks, you have a cylinder head that looks uniformly soaked in oil, from one end to the other, covering the entire perimeter of the valve cover. You bring it to a shop. The technician looks at the uniform oil coating, looks at the valve cover perimeter, sees what appears to be oil weeping from multiple points along the gasket line, and quotes you a valve cover gasket job. The diagnosis is visually logical. It is also almost always wrong, and experienced mechanics know it is wrong, and they quote the gasket job anyway, because the gasket job is worth $800 and the grommet replacement is worth approximately nothing in billable time. Let me tell you exactly how to fix this yourself in under 2 minutes. With a $3 part and your bare hands. You do not need a lift. You do not need special tools. You do not need to drain the oil or remove anything significant from the engine bay. Open your hood and look at the top rear section of the valve cover. On most Toyota four-cylinder motors, the PCV valve is a small plastic or rubber nipple, roughly an inch tall, with a vacuum hose connected to the top of it. It sits in a dedicated bore, slightly apart from the oil filler cap. Disconnect the vacuum hose from the top of the PCV valve by simply pulling it straight off. It may be stiff from heat, so grip it firmly and work it side to side gently as you pull. Once the hose is free, grip the PCV valve itself with a pair of pliers, grip it firmly around the body without crushing it, and pull it straight up and out of the valve cover. It will pop free. Set it aside on a clean rag. Now look down into the bore where the PCV valve was seated. You will see the grommet sitting in there, or what is left of it. If the grommet has truly petrified, it may come out in pieces, so work carefully. Take a small flathead screwdriver or a pick tool and work the tip gently around the outer edge of the grommet, prying it upward incrementally. Do not stab down into the center of the bore aggressively, because you do not want any fragment of the old grommet to fall into the valve cover and end up circulating through your engine. Work slowly, pry from the edge, and ease the old ring out in one piece if possible. If it crumbles, take your time removing every fragment before proceeding. Once the bore is clean and empty, take the new $3 grommet, orient it correctly, and press it firmly into the hole using your thumb. You should feel it seat with a slight resistance as the rubber compresses to fill the bore properly. Press it until it sits flush with the top surface of the valve cover. Reinstall the PCV valve by pressing it straight back down into the new grommet until it seats. Reconnect the vacuum hose to the top of the valve. You are done. Within one heat cycle of driving, the new grommet will compress and conform perfectly to the bore. The pressurized oil vapor that was escaping will now flow cleanly through the valve as intended. The spray of oil onto the top of the engine will stop immediately. The burning smell coming through your air vents, caused by oil vapor hitting the hot exhaust manifold nearby, will disappear entirely. The terrifying lake of oil coating your cylinder head will not grow any further, and after a careful cleaning with some engine degreaser, your engine top will stay clean indefinitely. The industry knew this grommet existed. Toyota published it in their own service literature. The part number is findable in seconds. The $3 replacement ring is available at virtually every auto parts store in the country, and if your local store does not stock it, you can find it online overnight. The fact that this repair is not the first thing every honest technician offers you when you present with this exact symptom pattern is not an accident. It is a structural incentive problem built into how shops make money. A $3 part and 2 minutes of labor generates no meaningful revenue. An $800 valve cover gasket job generates real profit. And terrified owners rarely push back when a confident technician uses words like catastrophic seal failure in their explanation. Share this video with every Toyota owner you know. Your neighbor with the Camry that smells like burning oil deserves to know this. Your coworker, who just got quoted for a valve cover job, deserves to know this. This information costs them nothing and saves them everything. And come back next week, because I have obtained internal documentation from a major parts distributor revealing exactly how a specific brand of synthetic oil additive, aggressively marketed to older vehicle owners worried about engine wear, is actually accelerating seal degradation in aluminum block motors and creating a second wave of exact, predictable failures that the same shops are already positioned to profit